In this video, you will learn about the preparation of esters and purification of esters. Esters are prepared from carboxylic acids and alcohols. Esters are derivatives of carboxylic acids, and the catalyst used here is concentrated sulfuric acid. For example, propanoic acid reacts with methanol to give methyl propanoate, or ethanoic acid reacts with propan-1-ol to give propyl ethanoate. Esters are prepared by a process called reflux. The reactants, carboxylic acid and alcohol, are heated for an extended period of time, and the catalyst used here is concentrated sulfuric acid. The vapors produced upon heating are continuously condensed back into liquid form. Now, this prevents the loss of the reactants or products, and at the same time, the rate of the reaction increases on heating. This is a reflux apparatus used to prepare esters in a lab. There's a condenser, water outlet, round bottom flask, and the heating mantle. Now, the heating mantle is used because the mixture cannot be heated in a direct flame, and that's because alcohol is flammable. And we use a round bottom flask to ensure uniform heating. As for the condenser, the vapors of the heated mixture rise up the reflux column into the condenser. Cold water runs through the condenser where it absorbs the heat from the vapors, causing them to condense back into liquid form and falls into the reaction mixture. Now, this process continues till the concentration of the ester increases. Once the ester is prepared by reflux method, then it has to be purified. The reflux mixture has the ester, some unreacted alcohol and carboxylic acids, and the catalyst, that is sulfuric acid. Purification of ester from other components is done keeping in mind that esters have low solubility in water. So the steps for purification of esters are: number one, the reflux mixture is poured into a separating funnel. Then water is added to the separating funnel. The mixture separates into two layers because they are immiscible. So here are the two layers. The upper layer is the less dense organic layer, and it has the ester and some leftover long chain alcohols and carboxylic acids, which are insoluble in water. The lower, more dense layer is the aqueous layer with water and sulfuric acid, which is soluble in water, and some soluble short chain alcohols and carboxylic acids. The next step is the aqueous layer is discarded by letting it flow out of the separating funnel. Then sodium carbonate or sodium hydrogen carbonate is added to the organic layer to remove any carboxylic acid in it. Carboxylic acids react with carbonates or hydrogen carbonates to form sodium carboxylate, which is water soluble, and the carbon dioxide gas escapes from the reaction mixture. Water is again added to the separating funnel, and again we have two layers. The upper layer has the ester, and the sodium carboxylate dissolves in the water, which is the lower aqueous layer, which is then discarded. The last step is distillation. The ester still has some contaminants, such as unreacted alcohols and carboxylic acids. Now, based on the differences in their boiling points, the ester can be distilled out and separated from the impurities. So, in the workbook, you will get to practice questions on preparation and purification of esters. So, good luck and enjoy.